Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CIPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. In today's session, we will be seeing about exception handling and templates in C++. What is an exception? An exception, as we all know, is an unusual condition that occurs in any situation. So, in C++ programming, when such an exception occurs, how to handle it? Why do such exceptions occur? So, we are going to see about all these in today's session. Exception handling is a process of providing an alternative path of execution when the application is unable to execute as desired. So, you are writing a program so that it solves some purpose. So, if that purpose is not being solved and the program is showing some other kind of execution than what you actually expected it to do, then what is the other path of execution that you can provide? If not this result, at least the program should be able to do this in case an error arises. So, that is the concept of handling that unusual condition. It is used to handle runtime errors in a program. See, runtime errors are something that occur when the program is in execution. So, normally during that time the programmer cannot get in between and make changes. So, while writing the program itself, the programmer has to imagine or he has to analyze what all possible errors could occur in this particular problem or what all errors could occur in this particular execution, and he should provide a method for alternative execution while programming itself. Only then during execution when errors arise, the program will be able to follow the alternative path that was provided by the programmer. So, how is all this done in this programming domain? An exception can be defined as an unexpected event that occurs during the execution of a program. It disrupts the normal flow of execution. So, it does not do what is expected of it. So, what are the kinds of exceptions that can occur? Such unusual situations is insufficient memory. See, when the programmer is writing a program, he does not know how much of memory space is available, but only during execution when memory is being allocated and depending upon the number of tasks currently running in the computer, the computer will be able to decide whether it can give its memory or not. So, when memory cannot be given by the computer or the compiler is not able to allocate memory for a variable, obviously the program cannot continue. So, in such situations there has to be some indication that because of such and such a situation we are not able to execute the program and there should be a graceful degradation. So, that is one particular error which is out of the programmer's control. Another one is arithmetic or array overflow. Like during the execution process, because of some input given by the user, whoever is using that particular program, he might have caused some arithmetic error, like he might have given such an input that at one particular point there will be a division by 0. Any number that is divided by 0 leads to infinity. So, all that cannot be displayed on the screen because such a computation does not make any sense at all. This error might not have occurred if the programmer had given a different kind of input. So, once the input is given and the program has proceeded with the execution, suddenly when such a situation arises, the system has to come to a halt or it will not be able to. What can the system do with an infinity value? It cannot perform any computation. So, there has to be some kind of a alternative path that indicates to the user that such and such a result has come. So, because of that we are not able to proceed with execution. So, we are terminating the program. So, these exceptions are out of control of the person who writes the program, because whoever is using the program only gives the input. It is not necessary that the person who writes the program alone has to use it. So, all these situations have to be handled while writing the program itself. So, that is only called exception handling. So, how does C++ handle exceptions? One way is a function terminates completely. It will just abruptly stop the execution of the program, or the function in which the exception has been raised may generate some message to the user. This gives a graceful look. The function may skip certain steps of execution and proceed to another section. So, there are 3 ways: either the entire program terminates, or the function simply gives a message on the screen that such and such a problem has occurred. The third step is the place in the program where the error has occurred alone is ignored by the compiler and it just jumps to a fresh section of the program. This is possible when a program is made up of different modules. So, if one module error has occurred, immediately the program will jump to another module. So, these are the three possible ways in which C++ handles exceptions. Types of program execution: we have the normal execution of a program, erroneous execution and abnormal execution. So, what is the meaning of this normal execution? From the name itself you should be able to identify. When the function executes as per our expectations, it returns a value indicating that it has successfully completed its execution. This result only indicates whether the function is executed correctly or not. So, this result is called the function's result code. Every function's result code represents the range of possible outcomes of function execution. See, when you are having a function perform some arithmetic operation, you will not be getting a character result. You will be getting a result which involves numbers. It may be a decimal or a float, but your expectation is that a function which is performing arithmetic operations will give an arithmetic result. Similarly, a function which is using strings, you are having a function display strings means the result of that function should be a string only. It will not be an integer. So, like this, every function has a range of values. The user or the programmer expects some range of result from a function. So, when a function is able to produce that result, it is called the normal execution of a program. Erroneous execution. Erroneous execution is, it is not necessary that the first time you write a function and execute it, it has to give that result. So, erroneous execution, there may be some errors, but which can be easily rectified by the program. It is not that if such an error occurs, the program has to halt or the system hangs up. They are minor errors which either the program compiler itself can rectify or the programmer can rectify in the next execution, or which gives a wrong result. Like the program will not halt, but the correct result will not come. That is only called an erroneous execution. It occurs when the caller makes a mistake in passing arguments or calls a function out of context. He does it by just some kind of an ignorant or thinking, or because his attention is diverted. This generates an error. It should be detected by some message that needs to be specified during program development. So, this normally can come because of a message like we have the if else conditions, isn't it? So, if the result comes within this range, you give some message, otherwise you give another message. So, like this, just by simple if else statements itself, you can identify these errors and you can correct them. They do not lead to abnormal situations. Normally any person can make a mistake. So, similarly like that, small errors that are made during program execution are indicated to the programmer. This abnormal execution is where normally we go in for exceptions. It includes situations in which conditions outside the program's control influence the outcome of a function. So, this has nothing to do with the way the function is being written or executed. These are situations which are outside the control of the person who is writing the program. Such situations cannot be handled with simple if else statements. So, simple checks or simple conditional statements available in C++ cannot detect or correct these errors. They have to be handled specifically. As we have seen the same examples: insufficient memory, I/O operations, non-availability of some device, non-availability of memory, division by zero errors. All these errors are abnormal executions, like the compiler will not know what it has to do next. So, in such situations only it needs the user's intervention. So, that is where we come into exception handling. It's a standard facility to deal with runtime exceptions. It's a well defined mechanism which can be adjusted by the program. It doesn't have a very strict path to follow. There is a skeletal structure available in C++ which we can modify according to our need, and it is implemented using three distinct components. You have the try, catch and throw statement. So, whenever we say exception handling itself, immediately these three keywords have to come to our mind: try, catch and throw. Exception handling means try, catch, throw construct. They are a construct, they come, all three come together. So, what is this try statement? It is a demarcated block of program statements called the guarded section. So, try indicates to the compiler, the programmer, the user that the statements which are present within the try block can possibly create an error or an abnormal situation. So, that section is called the guarded section of the program. Generally, when you are writing a program, the entire program cannot create an error. The error can be created only in places where we are performing some calculation, allocating memory, doing such sort of things which only when the program is executing we will know whether it will be successful or not. So, only that part of the entire program is placed within the try block, that is called the guarded section. The section of the program that could possibly generate an abnormal situation is called the try block of statements. Catch. Catch is nothing but the block of statements which provide the solution or the path that is to be followed when such an exception arises. So, a set of functions called catch handlers which are executed when an exception occurs. So, try indicates to the compiler where possibly an error can come. Catch is nothing but what has to be done when the error occurs. So, in between these two there is something called the throw condition or throw statement. This expression indicates to the program to jump to the statements at another location. See, we are having a try block which can generate an error. We are having catch block which should handle the error, but it is not necessary that there will be only one try in a program and one catch in a program. There will be several try blocks in a program. There will be several catch handlers in a program. So, which try block's exception should be handled by which catch handler? So, the connection between the error and the catch statement is done using this throw. The throw statement has a parameter. The keyword throw is followed by a value which indicates the nature of the exception. So, based on the nature of the exception only, the particular catch handler will be executed. So, these are the three keywords that are to be used in the exception handling construct. We will see the execution of this try, catch and throw statements, how they are used in the program after the break. So, we will see the execution of this try, catch and throw construct and how they are used in exception handling. We first see the rules that are to be followed when applying this try, catch, throw construct, and then we will see a couple of programs, so you will have a better understanding of how it is used in the programming paradigm. The first step is control reaches the try statement by normal sequence of execution. Just as how the program is being executed, we come across a try set of statements in the execution. The guarded section within the try block is being executed. If no exception arises, like the possibility of an exception to arise only is indicated by the try block. An exception may come or it may not arise. So, if no exception is thrown during the execution, the catch blocks following the try block are ignored. This is obviously the case. Only when the error occurs, you have to execute the catch block. If there is no error, you just proceed with the program execution. Execution continues from the last catch statement following the try block. So, because all the catch handlers, all the exception handling mechanisms have to be ignored because no exception has arisen. So, all the catch statements will be ignored by the compiler and whatever statement follows after the catch clause is only executed. So, from that point the compiler starts executing the program again. This is a condition when there is no error. So, if an error arises, if an exception is thrown during the execution of the try set of statements, the program searches for a catch clause that handles the exception of the type that is thrown. See, after a try block, if an exception arises, we have the throw followed by a value which indicates the nature of the exception. That particular value is matched with the catch handlers. Whichever catch handler's value matches with the thrown value, that particular set of statements are executed. If a matching handler is not found, the predefined runtime function called terminate is called. So, this terminate is a predefined function present in the C++ library. So, if there is no catch handler, no exception handler for the particular type of exception, the compiler immediately calls the terminate function. So, this terminate function has its own set of messages. So, that will be displayed on the screen, that cannot be defined by the user, it is built in. So, we will see how this is executed with the example. We have the main function, we have the try block. Try means whatever statements follow this try block are called the guarded section. Here we are allocating memory integer to the variable age. Then we are asking the user to enter the age of some person. And what are we checking over here? If the age is in between 1 and 100, there is no problem, but if either the age is less than 1 or it is greater than 100, an exception has to be thrown. So, the exception, the value that is following the throw keyword is a string. So, this indicates the type of exception or the type of catch handler that is to be caught. So, a catch handler which can handle a string has to be caught. Then we are having cout after the throw statement and we are closing the guarded section. Here we are having only one catch block, and if you see, the catch block is followed by a string, character, indirection, dereferencing operator, pointer, followed by MSG. So, this invalid age is substituted instead of this MSG. So, what happens inside this catch handler? Cout error and then the message invalid age is displayed. Now, this happens suppose a value that is not in between 1 and 100 is given. Suppose a value like 60 or 50 is given, this exception will not be thrown at all. This invalid age will not be thrown. So, this will be ignored by the compiler. It will just print after the throw statement, ignore the catch handler, then it will print program ends here and it will close the main function. So, with the output now we will check how the program is executed. Case 1 is we are entering a valid age, we are entering the age 71. So, that means an exception is not thrown. So, how does the compiler execute it? It will ignore the throw statement, it will simply print after the throw statement and print program ends here. That is exactly what happens. In case 2 we are entering an invalid age. So, when we enter an invalid age, this particular error message is displayed and then program ends here. So, this is how the value that follows the throw keyword is matched with the catch handler value, and correspondingly that value is passed on to the catch handler and it is displayed in the catch block. So, here there is a try, one exception and one catch block. What happens when there is only one exception but 2 or more catch blocks are defined? Which catch handler will be executed? If a matching catch handler is found, the instructions in the catch handler are executed. If a matching catch handler is not found or defined for a particular exception, one particular option is the terminate function is called. The other option is you should have a default catch, that is which is having this particular format, catch followed by 3 dot operators or 3 period operators. So, this means this catch handler can be used for an exception of any type for which the particular exception handler is not defined. So, this is the default catch, like in the switch case statement we have a default case, isn't it? If none of the case constants match the condition variable, then we execute the default case. Similarly, this is called a default catch handler. So, if a particular exception's catch handler is not defined, this particular catch block will be executed. If this default catch is also not defined, then the terminate function is called. So, now we will see an example program with this catch handler. You have the main function, you are simply having the before try statement. Then here you are not executing any set of statements, you are simply throwing an exception. So, within the try block you are having throw 10.20. This is nothing but a float value. So, the value that is followed by throw indicates that this exception belongs to a float nature. And after that, if you see, you are having one catch handler with a string value. Float is not equivalent to string. So, this catch handler is ignored. Next, you are having a catch function or catch statement with an integer value. This also does not match with 10.20. It is a float value. We need a catch handler which is able to handle floats. So, this is also ignored. Next, we have a catch handler which is a default handler. So, because the float exception handler is not defined, this default handler will be executed. After that, we have a statement, program ends here and the function is closed. So, in the output statement, we will have the before try statement, we have the unknown data and we have the program ends here. So, though one exception is raised, the catch handler for that particular exception type is not defined. So, we go in for this default catch handler which is catch statement followed by 3 dots and the coding. That particular block is executed and then the statement proceeds after that execution. So, when an exception is thrown, the matching value or catch handler has to be identified. If it is not defined, the default handler is executed. If the default handler is also not there, the terminate function is called, and always throw should come within the try block, because only inside the try block the compiler will look for an exception, and an exception is thrown by the throw keyword, an exception is looked for by the try keyword, and an exception is handled using the catch keyword. So, these are the points that are to be kept in mind when we move into exception handling. Unhandled exceptions. If an exception is not caught by any catch statement because there is no matching catch block, the terminate function is called. What does this do? What does this terminate function do? It terminates a current process which displays an abnormal termination error message. The syntax for that is void terminate. This is how the function is defined. There are two types of exceptions in C++, synchronous and asynchronous exceptions. So, what are they? Synchronous exceptions occur during runtime. This can be generated using throw expression, can be handled using catch handlers, and control does not come back to the point from where the exception was thrown. So, once an exception is raised, it is thrown, the catch handler is executed, control continues after the catch block only. It will not go back to the try block. So, it will not go back to the point where the exception was thrown. It will continue only after the catch block. So, these are the normal types of execution, synchronous exceptions. Asynchronous exceptions are those which cannot be handled by this try catch throw construct also. They occur due to keyboard or mouse interrupts, that is hardware devices. They cannot handle these exceptions. The exception handling construct cannot handle these exceptions. A separate handler that automatically calls the associated routine must be created. Now, this is not for the programmer's point of view. This is for those who create the C++ library and to identify the errors in the software. So, as far as we are concerned with programming for our applications, these exceptions are not within our control. So, with this we complete the topic of exception handling. Next we move over to templates. Templates allow us to create a generic functionality, that is, normally we say integer data type, float data type. Suppose we do not know what data type we will be using when we are writing a program, we can simply give template data type. Any data type can be substituted instead of this template data type. It returns a value without having to overload the function. It is categorized into two types. A function can be template, a class also can have a template data type. So, how do we define these templates in C++? First we come to this function template. The declaration has this syntax, template keyword, the class ID or whatever data type ID you can give, that is your own definition. Then you have the function declaration. So, this is the example, template keyword. You should make use of this less than greater than operator, that is a must. Template class dt, instead of dt you can have t, you can have small dt, that and all is user defined. Okay. So, this particular term is user defined. It is your wish, you can give any name you want, but whatever name you give here only, you should use it throughout the program, that is a must. So, if you see the next statement, the return data type is also this dt, find is the name of the function, the parameters are also of this dt type. So, whatever template you use over here, the same name you should use over the function also, and then you are defining the function return if a is greater than b. If a is greater than b, return a, otherwise return b. So, this x will be substituted for a, this y will be substituted for b. So, that is how these functions are defined. You have to remember the syntax when you are using the template function, this is what is important. So, dt is called the generic data type. It does not represent any concrete data type. When the function is called, dt can be replaced with any valid data type. So, syntax is what you have already seen, function name, the pattern and the parameters, integer x and y, find is the function name. So, when you are calling that function, you should use the pattern like this. Here is where you define what data type is to replace the dt. So, when you give like this, that means that dt is replaced by integer and you give x and y as the parameters. So, this is how you call a function template. We will see this in the program. A class template can have data members based on generic data types. Their data types are not defined during class creation, like how when you are creating a function the dt is not known. Similarly, when you are creating a class also, the data types are not known. You simply have to give template class dt or t, and then you can define the data type when you are creating the objects. So, we will see how that is done. So, here you are having template class dt, class ex is the name of the class, again dt x and y, their data types are not known. In public you are having the constructor also you are having two data type parameters dt dt whose values are not known, and you are initializing the values n1 to x and n2 to y. So, nowhere the data type is mentioned, then the function constructor is closed. You are having dt max, you are defining a function here, but you are declaring a function here, you are not defining it. Here you are defining the function. Now, just see the syntax. You need to use this template class dt keyword. Dt is the return type of the function, ex is the name of the class, dt is the class data type, scope resolution operator, and max. So, this function max is defined over here. This is the syntax you have to follow when you are using template data type. So, what are you doing here? Again you are creating a variable of type dt. You are checking, you are finding the maximum of two numbers here. If x is greater than y, you are returning x, otherwise you are returning y. So, the val will have the value of this bigger number and you are closing the function. So, now we will call this function from the main program and see how it is executed. This is the way you create the object. Ex is the name of the class followed by this data type. So, this indicates that the class has having integer data type. So, when OB1 is created, you are passing the two numbers 15 and 7. So, this will call the constructor and initialize the values of x and y to 15 and 7. Then you are calling cout OB1 dot max. So, the max function will be called, 15 is greater than 7. So, the output will be 15. So, this is how you have to use the template class data type and replace the dt with the particular data type. Instead of integer you can give float or you can give a double value, and accordingly you should give the values 15.5 and 7.3 or something. So, according to that only template class data type is replaced. So, in today's session we have seen about exception handling and templates. The possible questions are the definition of an exception, an abnormal condition that arises during program execution. The exception handling construct is try, catch and throw. The general types of execution, normal, erroneous and abnormal. Types of exceptions, you have synchronous and asynchronous exceptions. Class templates are classes with a generic data type whose value data type is not known during class creation. Significance of the terminate function is when an exception is not handled either by the default handler or by a handler of its type, the function calls the terminate function, which is built in C++ library. So, these are the possible questions that could be asked in this session. With this we complete exception handling and templates in C++. Thank you.